All right. Okay. Uh, so what is the topic for the day? So let's quickly check that. So I'm covering this topic, which says diagnose network problem using tools such as debug, conditional debug, trace route, and ping. Okay, so we have already done syslog. SNMP is something which we will do in the upcoming classes. So for today, I'm gonna cover this topic, which is one of the part from the encore itself, and it's the session number 4. Okay, under network assurance. Now these are some of the tools which we often use uh, for troubleshooting, so which is also called as network utility. Okay, so these kind of tools are called as network utility tools, which let's say if we are trying to troubleshoot something, so this is something which we start from, right? So let's start with ping first. A very simple topic. So let me open up the GNS. Okay, and to demonstrate the backend of the ping, how the ping works, what is the backend packet. So I'm gonna consider this path, something like this. Okay, so all my topics for the day would be in this path. So might be for trace route, I'll try to do a trace route. For a ping, I might use this path. For a conditional debug, I might use this. So something where I can get few hops. Hops is nothing but from one interface to other interface. Okay, so it's called as one hops. The second hops would be this would be first, and now the second interface, the L3 interface, to the next L3 interface, you call it as two hops. Okay, hops is nothing but the distance your route, the neighbor router is located. So if I initiate a simple ping from my router Mumbai router 3, the first one, towards the Tokyo one. Okay, so what is the IP address of this? Let's check. So this is the lab which we have done in our OSPF, EIGRP, and redistribution topic. Okay, so I'm not going to do the OSPF EIGRP configuration once again. So it's already done in the previous classes. So let's see what is the IP address here. Okay, so I have my destination IP as this. So let's give it a try if I'm able to ping or not. Okay, so might be there is some issue. So basically what you do when a ping is not reachable, that means the destination is down, right? So how do you troubleshoot? You troubleshoot now in hop to hop way. You never know. So let's say how many hops do this diagram has, or this topology has. So it has like first hop over here, the second hop over here, and the very last hop over here. So you did a ping, you don't know what happened, it's failing. If you see this kind of dot symbol, that means it was down or it's a drop. That means the destination is not reachable. That doesn't mean that the issue is at the destination side. The issue could be intermediate path also. It could be issue with this interface. Might be the VLAN configured is wrong. Might be the cable connected is wrong, or might be interface is not functional, right? Or issue could be somewhere here. So you never know where exactly the issue is. So once you do ping, if you get these drop message, that doesn't justify the issue is at the destination part. It could be anywhere intermediately. So to have a clear vision, we can go with traceroute now. Okay, so I'll make use of traceroute command. So I'll take out the ping command and I'll make use of traceroute. So the full command on a router is traceroute. Okay, so when I do that, I see it's failing at my first hop. Okay, now it's clear that my packet is not at all going out, so that could be issue with my own source router itself. So let's check the OSPF neighbor, because it's a OSPF configured routers. I don't have any OSPF neighbors, so it's very true that the issue is exactly somewhere between this. Okay, now what could be the issue? If there is no ping, okay, ping is failed. If there is no trace route, what is the issue? So what, which OSI layer does ping or trace route basically correspond to? If you remember the 7 layers of OSI, the ping and trace route deals with the last three one. The last three, I would say, from the physical layer. Okay, physical layer, the data link layer, and the network layer. Okay, so if your ping and trace route is failing, that means the issue is with these three OSI layers, not with the top layer. They are the software layers. No, there is nothing that ping or trace route deals with the UDP or TCP or services. Okay, it's either might be the VLAN configured is wrong, or might be the interface is down, or might be cable is down. So you have your all three uh, components belonging to either network, data link, or physical, right? So let's see from current point of view. So when I do a ping or trace route, I was immediately getting failed at this part. That means my packet is going, I don't know, my packet is either going out or I'm not receiving any update. So yes, I can make use of Wireshark and I can analyze what is happening, right? But most of the time Wireshark will be not installed. In that case, you need to bring your networking knowledge. So you can do the physical checks. How can you do the physical checks? You can try to do a direct ping. Okay, so ping is not working, so it clearly says the interface has some issue. Okay, but let's see from trace route point of view. So I have a trace route which I have enabled over here. Okay, so let's see what is happening when I initiate a ping, whether this router is, whether the Wireshark is able to capture something. Because there could be two issues now. If you talk from networking point of view, one issue could be over here. As I said, the 3 layers issue. My interface is not configured right way, or interface, the physical interface is down, or cable is down, right? Or issue could be at this point. We are sure that the issue is somewhere here, but we need to check from both the side. So let's bring the Wireshark. I'll filter up for ICMP packet. Okay, and let's initiate the ping. So I can see the ping is being taken out. That means the ping packet is being seen, but I'm not getting any reply to that. So how does ping works? That's important thing that we need to understand. Okay, so how ping works and how traceroute works. So when I say that I can see some ping packet, then why is it failing? Why is it giving us the drop packet? Okay, so if I open up you this Wireshark capture, so let's go with the ping packet, which is ICMP packet. Okay, so I can see my ping from the source was sending some ICMP packet. Okay, Internet Control Message Protocol. What kind of packet it was? It was a type 8 and it was consisting of code 0. Now we need to understand what is type 8, what is code 0, what does that actually mean. Okay, so I have a chart where I have shown up all these codes. Okay, so if you see 8 with 0, type 8 with code 0, that's your normal request packet. That means your source is sending some packet, ICMP type 8 with code 0. That's a good packet, but your second router is not responding your reply packet. What should have it replied as? So let's say if I check this table, then this should have been the reply packet with type 0, okay, and code 0, but I'm not receiving that packet anywhere, right? So there is some issue from the destination point. Let's see from the destination point what is happening. Okay, uh, as you know, we have done quite of troubleshooting. I have also done a ping, I have done the Wireshark, so there is no issue at the source side. But yes, there could be issue at the destination side, and destination is on my first hop itself. Okay, so let's check first interface status, which is very important. And you can see the one of the interface is shown as admin down. Now, is that the right interface that you're trying to ping? Yes, that's the right interface, right? So that's why your interface is down, which deals with your physical layers. So that's why the ping didn't work, right? Now let's bring this up. So let's say no shut. Okay, and let's give a ping test. I am successful, right? So let's see what happened here. So if you see here, my 4 packets were successful, so there should be 4 packets. Okay, and prior to that, packets were all getting failed. Somewhere till here, the packets were getting failed, and then I see something happening. So I initiated a ping with 8 and 0, which is called as echo request. Okay, from 12 to 14. This is source and this is destination. What is my destination now responding? It's responding with 0 and 0. What is 0 and 0? It's echo reply. That means I can hear from my neighbor, the direct connected neighbor. I sent him something which is consisting of some ICMP code. What is ICMP? It's Internet Control Message Protocol. So we use this protocol inside ping. Okay, and this protocol has 2 types. One we use for request, that is this one, and the other one is to get the reply from the destination, that is over here. So once we get request and reply, then we say that the next hop is reachable to us. Okay, so let me do traceroute now. So let's say the one which I started with, that's traceroute. Let's do a traceroute. So what am I trying to traceroute? I'm trying to trace route my entire path from here to this. So I should see a lot of hops getting triggered up. Okay, let's do a traceroute, and yes, now it's successful. I see a lot of hops now. We call it as hops, HOPS. Okay, so what does this trace route with 3 hops suggest? So whenever I did a trace route to the destination, it's 3 hops away from the source. The first was this, second was this, and third one was this. Now the thing is, you get the hops when you're dealing with the L3 interface. If it was a L2 interface, you would not see any kind of information. So you see, intermediately you had some L2, it didn't trigger that. There was one more L2, it didn't trigger that. Okay, so the trace route will only trigger for the L3 interfaces. Okay, not for L2 interfaces. So if you see from the diagram, I'm expecting my first hop over here. My second hop would be this, and my third hops would be this. Okay, so that's why I see 23.14, which is this, I see 100.3, which is this, and finally 23.2 over on my third hop. Right now, what is traceroute consisting of? What kind of packet is it? Okay, how does these hops we see in the case of traceroute but not in the case of ping? Let me tell you, the traceroute works on ICMP as well. Okay, it works on ICMP as well, but yes, traceroute can also work on UDP and TCP as well, depending upon what operating system you use. By default, if you just wanna ignore this, you can by default keep ICMP itself. But yes, you can also make use of traceroute with the code like this kind of code, which will carry the TCMP traffic. If you make use of code like a U, it's gonna be considering UDP. So as I said, depending upon operating system, you can change the behavior of traceroute packet. But let's consider it as default, which is ICMP packet. How traceroute treat ICMP in a different way than a ping packet? Because in a ping, we know that we don't see any sorts of uh, such messages, right? It was a clear source to destination uh, information with respective to two different types of ICMP. One was request and reply. So let's see from the traceroute point of view. Okay, let's say I initiated traceroute and I check my Wireshark. So this were my ping packets. Okay, and now I started getting, I started receiving the traceroute packet. I initiated twice, so I see a lot of packet. But yes, if you want to check once again, let me do it once more. Okay, so somewhere after this packet are my current traceroute packets. Okay, so let me label them. So these are my traceroute packet. Now what has happened here? Okay, so if you see, I'm filtering it for ICMP. Okay, and I see 14, which is my first hop. Okay, then I have my second hop, and then I have my third hop. So how are they responding is, so let's say this is my router 1. Router 1 initiated some trace route to router 2. So I see the information from my first hop, that is I see this IP dot 14. So you can see dot 14 dot 14 dot 14. You don't have any information from this, right? There's something which you will understand in few minutes. So you're not able to say this source, you are always seeing some responses coming every time on my Wireshark that you see right now. Okay, so you have three packets for the first hop which responded back. The second hop responded back, once again three packets, and finally the third hop also responded back with another three. So it's very clear your traceroute is gonna work in three packets. Okay, it's gonna work in three different packets. And what is the relation between traceroute and these three packets? So let's say if two of the packet gets dropped out of three, it will be considered as down. Okay, so the criteria for your router to say that the next hop is up, it must pass that criteria test. Okay, at least twice out of three should be a successful reply. So how it works is, as I said, it's a ICMP packet. Okay, so you will see some packet coming in, the router is gonna reply back. Okay, and that's how it's gonna work. But we will see in depth, it's not just like how ping works, there are a lot of things which comes here. Okay, so let's open up one of the packet now. So let me open up this packet. Okay, and you can see the first hop is, okay, one second. Okay, the source to destination, it's starting from dot 14. That's your reply from your first hop towards the source. Okay, what else is it carrying about? It's carrying some type messages. Now it says type 11. What is type 11? So type 11 is for time exceeded. Now this is a new component in the case of traceroute. So how traceroute works is, and how traceroute is different than ICMP is, or the ping is. So in the case of ping, it's just a request and reply. Okay, so request is something which will carry your type 8. Okay, and this is something which will carry type 0. Whereas in the case of traceroute, along with these two, it's also gonna carry something called as TTL. TTL is nothing but, as I told you in the previous class, not in the previous class, might be in the switching looping, that in the case of switch, the loopings are infinite, there is no stop for that. But in the case of router, or in the case of routing, the loopings have some end point. Okay, That's because these packets carry something called as TTL, time to live. Okay, and the maximum TTL value can be 255 and the lowest can be 0. Now what router in the case of traceroute does is it's gonna send TTL with 1. Okay, so once this packet in ICMP format reaches to the first hop, the TTL is gonna get expired. Okay, as soon as TTL get expired, router has the tendency to reply back with some error. What kind of error? Let's see that. Okay, so it's gonna reply back with the some error, and that reply is now we get it in the form of hops. We see something like 192 168 32.14 gave us so and so kind of thing, right? That's because the TTL was expired and the router responded back with error. Okay, so let's see from the Wireshark point of view. So if you see my first packet, okay, so I can see it's giving some error, time to live exceeded, because TTL was decremented. So you had only TTL1 and the TTL is gone. It's expired. So once the TTL get expired, you have a dedicated ICMP code for that. Okay, so if you see over here, okay, so looks like I can get this fine. Not an issue. Let me use this pointer. So you will see that in the case of traceroute, this was the error that was sent by the router 2. Okay, it's sending the type 11 with 0, which is nothing but it says that time to live exceeded in the transit. So your router 1 had sent a TTL of 1 and it was expired. Okay, and this router sent back the notification. Now what happens is your traceroute table gets its first record of the entry. Okay, it's get that information that router R2, whatever IP you have configured over this interface 192.168.32.14, gave you some uh, log issues, or gave you some log. Now what is router 2 going to do? That's not the end. Okay, that's just the TTL got expired. It's not a issue with your traceroute. The traceroute will work in the same pattern. Now what R2 is going to do is R2 is going to send one more TTL but with value 2, so that first TTL will get expired here, which will result in one more TTL, left out with one more TTL, and with that TTL1 you can reach to the next box. Okay, so TTL1 got expired here, TTL2 got expired here, and now you're gonna get one more message with the same message type, that time to live exceeded. Okay, and finally the third router, it's with TTL3, 1 2 and 3. Now TTL3 will be pingable, you will get that message called as live, but apart from that there will be a different ICMP code error. Okay, now that code error will be something out of this. Okay, so you will see on your destination router, it will not look like your echo reply, which is in the case of a ping packet. It's not going to be very simple echo reply. It's going to be the destination unreachable. Why is it going to be destination unreachable? Because traceroute works on ICMP, okay, so that it knows what are the error code, but it's carrying some UDP packet within it. Okay, so what happens is my intention is to see if that UDP port number, let's say 32768 or 32, is up or not. Okay, that's a dummy thing which traceroute is gonna insert inside it. If you would have got the normal echo reply, don't you think it would have worked in a ping way? Because in a ping also you get echo reply, but it doesn't gonna document who is replying back, right? Ping is something which you get to see if the destination is up or not. Okay, guys, I'll place in mute. So ping and traceroute are different. They still work on ICMP. Ping is purely ICMP. Traceroute ICMP with UDP or TCP. As I said, you can make use of the way you want. So what exactly happens is when your traceroute gets initiated, the source is making use of UDP data. Okay, so it's gonna consist of source and destination UDP port number. Now there are some port number that these UDP is gonna carry. Okay, they will not be effective until we are talking about ICMP. So let's say in this way, I have ICMP added with UDP. Okay, so between R1 and R2, it's just about my ICMP, which is gonna carry those TTL values. Okay, UDP is not even considered. Once I go to my router 3, is once again the ICMP is getting bothered. So you get your respective code 11, okay, every time. So let's say you got the code 11, you got the code 11, and that's how you got your trace route table getting documented, that with the R2 with the R3. Now when you finally arrive to the destination, your ICMP is gonna work, right? And it would have given you echo reply. But how do you think the third router also you get it across here? Because you're sending some UDP packet as well. Now that UDP packet is gonna get considered. Okay, and what is the error that you will see on the final router? You will see destination unreachable, and it will be somewhere at this error code. Okay, so on your final hop, you will see type 3 with error code of 3. So these are some error code which will be helping you in forming the traceroute table. Okay, so let's see that from Wireshark, because once you do practical, you get to know more things about all this. Some minor things. Okay, so as I said, traceroute is gonna work on 3 datagrams. uh, 2 should pass. If they don't pass, then it's gonna considered as down at the first point itself. There is no way the trace route will work there. You will see some asterisk symbol. Okay, so you see there were 3 packets every time. You got the 3 packets from the second hop, and finally the destination gave you the 3 hops. So from first hop, you see TTL value of 1. What is the type? It's type 11 and code 0, which is over here. Time to live exceeded, because that's your first hop. So ICMP TTL value was getting uh, triggered. Okay, now it moves on to the second hop with TTL value of 2. Okay, you will not see here, but I'll show you the TTL value 2. Okay, so you just see what is the ICMP code. You once again got time to live exceeded. Okay, and every time the time to get exceeded or any sorts of error code that the ICMP face, it's gonna record it on the source router. Okay, so you get one more entry created on your this is the entry. Okay, for the type 11 TTL exceeded. Okay, now finally the third one, which was the real destination, it responded to the ICMP, but now with along with ICMP we also sent a UDP packet. Okay, and the code will be different now. If I show you the third hop, so you see now it's not about type 11, it's about type 3. And what is type 3? It's destination unreachable. Within destination unreachable, you have couple of them. It could be real IP from the layer 3 point of view. It could be DNS issue. It could be the fragmentation issue. But one of the concern or one of the issue here is port unreachable, which is code 3. Okay, and you see type 3 with code 3. So that means my source initiated the trace route with 2 components, ICMP and UDP. Why didn't I get that here? Because I'm filtering for ICMP. Let's trigger for UDP. And this is the real capture for the trace route that I should see. Okay. So if you see now, since I'm making use of UDP, now we can see all in and out packets. Okay. So let me show you from, okay, so where is the exact packet? It will be from 192. Okay, we can redo this so that I can show you from very first packet. Okay, I'll do trace route. Okay, so there are so many that it got. Okay, anyway, I'll do once again. Okay. It's too fast to actually capture them. So let me remember the sequence number 4306. Okay. Okay, 4306. Okay, so I have my first packet, that is 23 dot 12. Okay, which is nothing but this one, which is trying to send 3 datagrams to the first hop. I have 1, okay, 2 and 3. So you see these are the 3 packets which are for with respective to first hop. Okay, so let me mark here. Similar way, I will see 3 more packets with respective to second hop, and finally the third hop. Okay, so what is source and destination gonna use? It's gonna use UDP packet, and you see the port number. Now this is the port number which is being created by the source in order to get the very final error message of port not reachable, so that you get this kind of table generated. If the router don't see any error, it's just gonna send those echo 0 with type 0, and there will be no records getting created. Okay, so that's why traceroute is very different. Even though functionality is on ICMP and we use traceroute for step by step troubleshooting, but the functionality is little different in case of the trace route. Okay, so let's see from the packet point of view. Let's see what is the router 1 sending. It's sending time to live 1. Okay, what kind of packet is it sending? ICMP packet. Okay, so it's sending the UDP packet with port number 33434. Okay, now what is the destination gonna respond back? It's gonna use the ICMP packet. Okay, it's gonna say whatever TTL you sent me, TTL1, it's expired, and I'm gonna send you the ICMP error code. Okay, it responded back. Now that happens for 3 datagrams, and then finally it moves on to the second hop. But while sending to the second hop, now it's gonna make use of TTL2. Okay, so where is it? So it's over here. So if you see my screen, okay, now the TTL value is 2. Okay, so that my router 1 get bypassed to router 2, or I can say in this way, my TTL1 is gonna get expired here, and it doesn't have to close that connection. It has to send further because it's having the TTL2 value, right? So one will be utilized here, the second one will be utilized here. So while sending it back, So while sending it back, it's gonna trigger the TTL issues, something like this. It's gonna say it's type 11, that means uh, time exceeded or TTL value expired. So it's gonna send back. Okay. Now for the final actual destination, which was uh, which was this packet, right? 23.12 to 23.2. What is the time to live? So let me open that, and you see now the time to live is 3. You know why it is it 3, right? Because the first hop will be somewhere here, the second one would be here, and finally third TTL value. Okay, it's going to be the normal UDP packet now because TTL value is good. Okay, the ping is working because you're finally trying to do a trace route on this, right? So that's what your command was. You're doing a trace route on 23.2. So basically it is a right one. But if you would not sent that UDP packet, you would have received this code echo reply, and you would have missed the third hop. To get the record or to get the entries of the last hop, you also sent some UDP packet. Okay, you sent a UDP packet on 33440. Now this, there are some fixed UDP packet which traceroute works. It is in this range itself, 350 to 33 like 450. So between this they will use one of the UDP packet. Okay, so TTL good, ping good, but UDP failed. And for UDP failed, what kind of error you gonna receive? You're gonna receive this error, type 3. Okay, so do we see type 3 error? Let's analyze. So what is the response that the destination is gonna send you? So destination will send type 3 with 3. Now what is type 3 with 3? It's port unreachable. Okay, which port? UDP port is not reachable. TTL value is 1 because it has been decremented. Okay, so this is how the traceroute work, and for every error records, the router is also gonna send its acknowledgement. The acknowledgement will be in the error code format, and your source router will be faster enough to make that entry on this table. So and that's how you get this kind of different hop by hop. Okay, now let's say if I have to bring one of the interface down just as a troubleshooting point. Okay, so let's say I disable one of the interface from the second hop. Okay, E0/0 with shutdown. So yes, you will do first ping, right, which is what we normally do, and you see it's not reachable. So we cannot conclude that this is an issue with the destination, or we do not know the issue is straight away with this router or the destination router. The issue could be, as I told, with respective to the data link, physical and network OSI layer of either this or this or this. Okay, so what is the next network tool utility for troubleshooting? I'll make use of traceroute. And now you see I got successful output from my first hop, 23.14. Okay, so what is that 23.14? It's straight away from first hop, but then 2314 was not able to send further. So there is an issue between between these two. Okay, now you can see two things. You can see the network data link and physical layer of this as well as of this. Okay, so we will go to the router 4. Okay, the first thing that you see is what is the interface statistic before jumping to the routing protocol. So they are up. Okay, you can also see what kind of protocols you are running. So you are running OSPF protocol. Is the OSPF neighbor up? So you see there is some entry still with 3.3.3, which I think is not with R6. That OSPF is with this neighbor. Okay, so the OSPF over here is missing. Okay, you have done the interface check, it's up and up. You have seen the OSPF neighbor is down. What else can you see? You can see the drops. You can see if there is any queue, right? So we will check all the required things. I'll see what is the drops here. So I'll see what is my packet on this particular interface. Okay, so the thing is, on my interface, the last input was good. What does this line say? It's saying that this interface processed some packet out of this interface. Now that packet could be anything. So that proves that that interface was up and not down. There was no issue with the cable. If I do the same command on my router 6, we can see the interface wouldn't have received packet for couple of seconds now, or at least minutes now. Okay, so what is the interface? It's 0/0, 0/0, and you see for last 3 minutes 31 seconds there was no packet processed by this interface, and that interface is one of the important interface for my traceroute to perform 100%, right? So there is some issue with this interface. Now issue could be cable issue, it could be a simple admin shutdown by some engineer, or there could be some SFP module issues where the packet is getting dropped. So I would first check what is my interface status. Okay, so you can go with show IP int 0/0. So you see it's admin down, right? So there are a couple of things which you can troubleshoot, you can narrow down rather than first checking whether OSPF is up or not. There are a couple of other things that could lead to this kind of issue. So you see the input was 3 minutes back. Over here the input was being still processing. You see the input was processing because the packet is coming out of the router 4, but since the interface over here is down, it's not able to process them. Okay, what else can you do? If you have your Wireshark, you can enable, but Wireshark is something which you cannot integrate on your the Cisco box, like how you can do it on a Linux or something. Cisco box don't come with any integrated. So from my previous class, you can use the span or remote span, but that would be a lot of efforts for a simple troubleshooting. So simple troubleshooting can give you a lot of information. Okay, so what else can you see? You can see there are quite a drops happening. Okay, so there's unknown protocol drops, and so this is the interface, right? Show IP int ethernet 0/0. So you have protocol drops. What else? The last input for last 5 minutes is trying to show over here. Okay, you can see with the protocol neighbors, there's no neighbor. You can see the show logging. Okay, if you're making use of a proper syslog, you can see what happened on the interface, which is very important. So you see July 23rd, what is the clock here? It's 53, and like close to like 7-8 minutes someone made it down, right? The interface was made down. Now if you want to see who made it down, then you know what is a AAA server, right? We always use AAA server. So let's say if I had a AAA server, the centralized server, I'll quickly log into this and I'll open up this box, and I'll see the last A, which is nothing but accounting, and I'll see who triggered it off, I would like to know from that person, is there any change happening here? What's the purpose of putting it down, right? I straight away cannot bring this up. Might be that's for some reason that the interface was put into down. So after a couple of troubleshooting, if let's say it's all good and we can bring it up, so I know that this is the interface which has to be made up. So I'll just make the command no shut, and the OSPF will build. It will take its timers, whatever timers that we know that the OSPF works on, and then we can give a test once again if everything is fine or not. So there will be first packet getting dropped because of ARP broadcast, and then you have a successful result. Okay, so you see there's a successful result. So these are network utilities, ping, ICMP, and traceroute. Okay, so works on three layers: ICMP request, reply. These are the ICMP code. Okay, what is the packet format for ICMP? It's very simple packet format. It's gonna consist what is type, what is code, and checksum. Checksum is just for error detection. Okay, just two important component is ICMP gonna consider, and nothing else. What are those error code where your router is gonna respond back? They are these code. Okay, so for type 0, code 0, there will be no entry made. Okay, and for type 8, there will be no entry made. Otherwise, in the case of ping, I would have received multiple entries, right? But which I do not see. That's because the router only respond for error code, not for the other codes like 8 or 0. So these are the types of the code where you will see the router responding. It can be on 12, on 11, or 5, or 3. What about the trace route, the second part which we discussed? So as I said, the first TTL will be 1. It's gonna carry the ICMP and UDP packet. The R1 is responding back with one of the error code which is 11 saying TTL expired. It's gonna send the TTL with 2 now. It's gonna respond back. It's gonna send now 3. It's gonna respond back with the type 11. Now it's gonna finally send the TTL which will be able to ping this. But since we are also sending that UDP packet on some port number, so it's gonna give the error code for respective to the port reach unreachable. Okay, so that's missing here, which I included in my above screenshot. So you will get this, and finally we see those hops by hops. Now the thing is, while you do a trace route, if you see this asterisk symbol, don't pre-assume. So let's say if interviewer asks you a simple question that the ping was reachable and the trace route were not reachable, right? Or let's say the devices are up, they are working fine, the services are working fine, but the ping and trace route doesn't work. The reason is, as you know, they work on something called as ICMP, and intermediately, let's say if this was a firewall, so firewall is gonna drop these packet. It might allow UDP, okay, it might allow the TCP packet, but there's possibility that ICMP is blocked. So in such scenarios, even though they are reachable end to end, but your trace route will not work because of the fact that the ICMP was dropped. Okay, so when the ICMP is dropped, so basically what happens is you're gonna get these asterisk symbol. Okay, so always trace route or ping is not a genuine way of troubleshooting, especially when there is a firewall intermediately in your hops. Okay, so most of the time when you initiate a ping from the access point from your host towards public internet, you will not see firewall. You will see most of the time as routers. Okay, so let's say if I open up my CMD utility and I do a ping to the Google server. So ping is down. Let's see what is traceroute doing. So the traceroute command in Windows is trace RT. So you see the ping failed because of the fact ICMP might have blocked, whereas your next thing, that is traceroute, you see that there's some device intermediately, okay, which is responding in IPv6 format, and that's how it works. Okay, so let me take some other host or a server. Let's go with Facebook. So this is because my modem is responding on IPv6. If I disable my modem on IPv6, I'll get a IPv4 output. It's taking time. Let me straight away put some IP address. So this is my modem. Okay, so from modem it said some request timed out. Is going out now. So these are the commands that we have for different platform: Windows, Linux, and Cisco routers. Okay, and yes, as I told you, the limitation of traceroute, it will not discover on a router level. Okay, it will discover on a interface level. So that's why your L3 counts every time. So this was a L3. It gave you what is the IP of that interface. It's not going to respond on the router level, not on the management interface or something. It's straight away responding on an interface. Okay, that's the first thing. Second thing, limitation is in case of firewall. If you have a firewall somewhere kept here, let's say this was a firewall, your traceroute would have failed, okay, with lot of asterisk symbol. That doesn't mean that the path is wrong or they don't have any communication. They might have communication, but traceroute is not a right way to deal in such scenarios. So if you are the network administrator of your own firewall, you can allow the traceroute path and it will work. So you have to allow those packets. Okay, and the third one is in the case of load balancing. Let's say I had a load balancer here, F5 load balancer, and you know that in case of F5 load balancer there will be lot of interface IPs. Okay, there is something called interface IP, there is something called as floating IP, right? So when you trigger the traceroute, you will see some IP from the floating IP which will not look like an interface IP. It will look something out of the path, and you will be stuck troubleshooting that where exactly this floating IP is in your network, and that will take a lot of time. That's why I say when you go on a P1 call, on a priority calls, when you do a troubleshooting on a enterprise or on a data center, you normally go with ping and trace route, right? There are a lot of time that the trace route will mislead you. Okay, so let's say you got a trace route output, your first hop was good, okay, your second one was good, and the third one was giving you some IP like 192.1.1.1, and then it finally was dropping. Now you will of course be looking where is this IP so that you can take a login of that, and then you try to see what is the next device or something. But problem in having a load balancer in your trace path is that this IP is a floating IP. Floating IP sense is it's inside your LB. Okay, and no way you're gonna get this IP easily. So basically what you would do is, when you get these IPs, you can directly SSH on those IPs. If you get 1.1.1, you can do SSH on 1.1 and you can log in, but these IPs you cannot SSH. And only thing that is gonna work is your inventory. If you're maintaining some LB inventories where you can input this IP, it should give you the host name of that LB box or the load balancer box. You can log in with the management IP, and then you can see cross verify whether that floating IP is within that LB or not. And from there, you can run the route command. You can see if the interface is or the route is configured on a proper next gateway or not. So troubleshooting becomes little hectic when you have these firewalls and LB intermediately. Okay. So what is my CMD going to give me? Is it going to give something? So it's slow. Let's ignore this. Okay. You can try it on later on. The command is traceroute for Windows. Okay. And for Linux, it's trace route. And these are the shortcuts. Okay. If you need specific filtering, you can enable them. Fine. So that was with ping, ICMP, and traceroute. The final short topic that I have is conditional debug. Very simple topic, and I would say that these conditional debugs don't work on these older boxes. Okay. So I may not be able to demonstrate the working, but I will show you what are the commands to do that. Okay. It's very simple thing. Let's say if I you all know what is a debug, right? So if I make use of show debug, there is no debugging now. If let's say I enable debugging on ICMP packet, let's say I debug on the OSPF packet. Okay, I'll get a lot of OSPF packet events, everything from all the interfaces that ICMP that OSPF is responding to. So you see, and basically we do not encourage using debugs in the production, because this is going to give me from all the interface that OSPF is responding to. So how if I restrict this? Okay, so what I would do is I take this out. Okay, and I would go with some filtering. So I would say debug with some condition. What condition? I need uh, the OSPF packets to be recognized on few interfaces. So let's say with respect to interface. Okay, so what interface I have here? I have E0/0, E0/0. Okay, and enter. So you're gonna see something like condition 1 set. Okay, now this is for enabling debug, at the same time enabling with respective to filter. Okay, so now OSPF will be only corresponding to this particular interface. So that's what this for this debug was related to. Okay, so what else can I have in my condition? So let's say I have IP. Okay, so let's say go with interface. So there is something called as Ethernet. Okay, there is something called as loopback. So you can enable these conditions. So now what happens? The messages, the debug messages on other interface are not being considered. Okay, the only message that will be considered is on this interface. And once again, the conditional debug will not work on GNS. Okay, it's a limitation from the GNS side. You can try it on EVNG or packet tracer. Packet tracer, I'm not sure whether that command will take, but on GNS this doesn't work. Okay, so that was something which I wanted to show from the topic point of view: debugs, condition debug, traceroute, and ping. So that's all from my side. If you guys have any doubt, let me know, and we shall meet in the next class. So you guys can unmute yourself and let me know if you have any doubts. Okay, so there's one question: as TTL is expired, then how TTL is increasing in next packet? Okay, so basically what happens is, I'm not sure whether the topic was discussed when you put this question. So the TTL will increase when it has received the error from the first hop. Okay, so as you know, there were 3 datagrams sent, and the datagram were sent with TTL1 for the first time. Now the TTL got expired over here. As soon as it hits the router, it's going to expire, and there is where you got your type. What was the type? It was 11, right? So you got the type 11. So once you get receive this type 11, there's an entry getting added up. Now the router will send the next TTL or next packet with TTL of 2. So it goes with increment of 1 every time. So now it's go with 2, which will hit here and it will come back here, and the TTL is gonna be 0 because it took 1 here and the left out was 1, which got 0 the time the TTL expired, and now it's gonna send back that information that TTL got expired, and it's gonna make the second entry. So when the entry happens, the next TTL will happen for TTL 3. So that's how happen. So this entry followed by this entry, the router is gonna send the next packet with the incremented TTL values. All right, okay. Fine, guys. So I take it as no, it was a simple topic which you all might be aware of. Okay. So I'll pass on the video and I'll pass on the recording. There's no lab for this, but yes, you can power on few of the devices. You can bring the OSPF or whatever protocol you're good at, and you can just see how the ping and traceroute work. But yes, I'll include this in my notes wherever it's required. What is the code, what is the UDP destination, all those things I'll include. But if you want to practice, then you can bring any device. You can take at least this, which was for BGP. If you need something else, you can bring and you can just try how it works. Okay, so the L2 will not be considered in the case of traceroute. It's always L3. Okay. Yes, if a firewall with L3 interface is responding to your traceroute packet, then firewall will also be part of your hops. It's that by default firewalls will deny implicit, right? So that's why most of the time we will see the drop symbol coming on if a firewall is intermediate. But if you have allowed it, then the firewall interface will also be one of the hops in our whole list. All right, guys. So let's meet up in the next class. Take care and see you soon. Okay.